Okay, let's now discuss growth and decay. This is an application of verbal problems leading to growth and decay for differential equations. Now, the initial value problem. Okay, the initial value problem dx dt equals kx, where x of t sub o is x sub o. This simply means that okay. This simply means that when t is 0, okay, when t is alright, t sub o, or usually this is x. Usually t sub o here is 0. Okay, our x is x sub o. So that is the meaning of that. Where k is a constant of proportionality, serves as a model for diverse phenomena involving either growth or decay. Now, this is the general formula. X sub t is x sub o e to the kt. If there is growth, then k is greater than 0. If there is decay, then k is less than 0. Now, let's derive the solution for this one. Okay, let's start with, of course, dx dt is kx. Now divide here. You can divide both sides by what? By x. Transfer dt to the right. So this equation will be the same as this. Dx over x equals k dt. Then you have to get initial condition, that is when t is 0, x is x sub o. Now, you can integrate both sides. Okay, of course you can integrate both sides. You have what? Integral of dx over x is integral of k dt, and this will give you ln of x equals kt plus ln of c. Now if you solve for x is e to the kt plus ln of c, and this is the same as x e to the c e to the k c to the kt. Now observe that this is the same as e to the kt. This is the same as okay, this is the same as e to the what? This is the same as e to the kt times e to the ln of c. And you know that e to the ln of c is c. Therefore, this will be our model. And of course, when you substitute t equals what? When you substitute t equals 0 and x equals x sub o, then you can find that x sub o is equal to c e to the 0. Therefore, our c is what? Our c equals x sub o. Therefore, plugging the value of c there, you have the model x is x sub o e to the kt. So the solution of what? Okay, the solution of this differential equation with this initial condition will be x equals what? X sub o e to the kt. Okay, let's have an example for this decay or linear model for decay or growth. Here, a certain population of bacteria is known to grow at a rate proportional to the amount present in a culture that provides plentiful food and space. Initially, there are 250 bacteria, and after 7 hours, 800 bacteria are observed in the culture. Find an expression for the approximate number of bacteria present in the culture at any time. So actually here we're looking for the model. Our model is, remember, x is equal to what? X sub o e to the kt. Now Determine the approximate number of bacteria that will be present in the culture after 24 hours. So when T equals 24, actually what is X? Basically that's the question. After the model, okay, after this model, after we can find this model and determine the amount of time it will take for the bacteria to increase to 250. It means time is unknown, then X is what? 2500. So let's solve for A. Our model is of course X sub T is what? X sub O e to the what? E to the KT. Then, alright, this is the condition. This is our condition. Okay, X is, alright, X is what? X is, X sub O is, X sub 0 is X sub O, that's 250. So we know already 250 here. Now X sub 7 is, X7 is 800. Now, okay. So we have to, this is the model that we're going to use. X sub T is X sub O e to the KT. For X sub T, we know X sub O already. X sub O is 250. That's 250 e to the KT. Our problem is to determine K. The condition given is that what? There are 250 bacteria after, rather, there are 800 bacteria after 7 hours. So here we can use this. 800 is 250 e to the 7K. Here we can solve for K. Now solving for K, okay, you have what? Get the ln of both sides. Okay, of course, get the ln of both sides here. That is ln of 800 over 250 is equal to what? E to the 7K. And therefore, we can solve for what? We can solve for K. Now, this K is approximately equal to, that's 0.1, 0.1, okay, 0.166164. So that's the value of our K. And our model now is this one. So we have found the model. Our model is, or the linear model is 250 e to the ln of 16 over 15, or that's the same as 0.166164t. Okay, next question is determine the approximate number of bacteria that will be present in the culture after 24 hours. So all we have to do is what? To use this formula, this one. Use this formula now. So we just substitute what? We just substitute 24. So substitute only, so we're looking for x24. Substitute 24 in this equation here. So you get, substitute 24 there, 250 e to the ln of 16 over 15 over 7 times 24. You will get what? You will get 1,000, or rather 13,486 bacteria. Okay, next is determine the amount of time it will take for the bacteria to increase to 2,500. So we'll go back again here to this model. We just substitute 2,500 and solve for T. So it means find T if x of T is 2,500. Then our model again is x of T equals 250 e to the ln of 16 over 5 over 7t. Then substitute 2,500 equals 250 e to the ln of 16 over 15t. And then you can solve for what? You can solve for time. Just get the natural, divide this by 250 and get the natural logarithm of both sides. Then you get t. Your t is, okay, 13.8573 hours. Now this problem can be solved using the curve fitting in the calculator. Now if you have a 991 ES, okay, this is okay, this model, this calculator is a 991 ES model, Casio. Okay, okay, all right. Have this mode 35. Okay, you will be presented by a table here. Just input the value of these values, variables. When x is 0, y is 250, and when x is 7, y is 800. And then afterwards, you enter clear, okay, to put a blank screen. Now, this calculator, okay, this model, okay, this statistics model models the equation y equals a e to the bx. So observe that this is the same as this model that we have here, this one, this model that we have there. So what you do is, okay, enter shift 151, you will get the value of a, which is 250. There is that 250 there. And then get shift 152, you'll get the value of b, which is 0.16616. Okay, that's the same as this one, this value. So we have the model already. We know the value of a and we know the value of b. So you now have, what's the model? The model will be what? The model will be 250 e, the 0.1660, and then to get the value of number of bacteria after 24 hours, just enter 24 shift 155 equals, you will get 24, it's y hat, and then you get this value 13,485.99. and to get the value of the time when x when okay, when the number of bacteria is 2500, enter just 2500 shift 154. Okay, by the way, this you will get the value, this should be 2500, that is 2500 exact. Okay, and then you will get this value 13.857.